Today we're going to talk about something that we learned in Algebra 1 but may have forgotten in Algebra 1 from Algebra 1 because equations of lines are typically written in slope, intercept, form, and you may remember what that equation is. The equation is y equals mx plus b. And from this equation, m represents slope. And I'm going to put a double star by that. And the b represents the y-intercept. The reason that I put the double star on the slope is that it goes here, which is just a little ways down your paper, and it says, remember, when trying to find the slope from a graph, use the idea of rise over run. So what I also did is I wrote rise over run here. It doesn't matter to me whether you write that there or not, just to remind us that that is what slope stands for. Rise over run. And what we're going to start with today is we're going to write equations of lines given the graph. So here's our first picture. Your pictures on your paper show up a little bit better than what they do up here on the smartboard. But what we need to do when we're looking at the graph is we're going to identify the y-intercept and the slope of each line. Then we're going to write the equation for the line. So y-intercept, again, is abbreviated with a b, and it's where the graph crosses the y-axis. So as we look at this point right there, that is where the graph crosses the y-axis. And what is that value? Well, that value is the origin, and it happens to be the y value of that origin is 0. But we also need to find the slope. Slope being the rise over run. So let's look at our graph a little bit more closely. And what we can find is that this point right here is a point right on the corner, and this point right here is also a point right on the corner. But when I count, I usually start from the y-intercept. And when we count from the y-intercept, we count rise, 1, 2, 3, and then we run 1 to the right. Again, slope is rise over run. And if you don't want to write 3 over 1, then 3 is fine. Notice if we go back and look at the very bottom point that we have drawn in, the bottom green point, from that point we go up, rising 3 to the right 1. That gets us to the y-intercept. And the slope of this line should be the same everywhere on it. And once we get those two pieces of information, we can fill them back into our equation, which is going to be y equals m x plus b. And some of you may be thinking, do I really need to write the 0? You don't really need to write the 0. Sometimes people are very literal learners, so they like to have everything in front of them. And when you write the plus 0, you can identify the fact that the slope is 3 and the y-intercept is 0 without having to figure out what the y-intercept is. Either of those answers is fine. Same kind of strategy here. Identify the y-intercept, identify the slope, and then write the equation. Well, the y-intercept on here is where the line crosses the y-axis. And I just filled it in, and it looks like it is 1. And then find a couple more points on the graph to identify what the slope is, slope being abbreviated as m. Again, your picture on your paper is a little bit better than my picture up here. But to help you out, I just filled in a couple of points. And what we're doing on this problem here, from the y-intercept, I'm going to count rise, 1, 2, up, but then I'm going to go 1, 2, 3 to the left. Or from the y-intercept, we could go down 2 and 1, 2, 3 to the right. The rise means that we're going to be going up or down. The run means that we're going to be going right or left. And what we see either way there is 2/3. But what I'd like to point out is that when we're coming from the left, our line is kind of going downhill. And what does our sign need to be if we're going downhill? Well, it needs to be negative. And if you look again at our picture, from the y-intercept, we rose 1, 2, and then we ran to the left 1, 2, 3. So when we go in the left direction, that's a negative. Going up is positive, left is negative, and positive divided by negative is negative. Same idea, starting at the y-intercept, we can go down 2, there's our rise, I say in quotation marks, down 2, to the right 3. When we're going in the downward direction, that's a negative. Going to the right, that's a positive. And negative divided by positive is negative. So one of those 3 ways to help us figure out what the signs are. But once we've got that information, we can put this information back into our slope-intercept equation, which is y equals negative 2/3 x, there's the m, plus b, which is 1. If you haven't done so already, try that third one on your own and see if you can come up with the equation of the line. Did you get y equals negative 1/2 x plus 2? Our y-intercept is 2. Our slope is negative 1/2. And that was looking at the graph and then translating the graph into an equation. We can go the other direction. We can graph a line given an equation. And our directions say graph each line given below. You may need to solve the equation for y first, because slope-intercept equation is y equals mx plus b. But luckily on this first one, we do not need to do that. But as we identify, what's the y-intercept in this graph? And hopefully at least you're thinking 5, which means that the negative 3/4, the other numerical value in this, is going to be our slope. And when we start, we graph b first. I oftentimes say b comes before m in the alphabet, so we need to graph b first. So we're going to graph 5. Remember, that's a y-intercept, so it has to be on the y-axis. And from that point, then, we're going to do the slope, which once again is rise over run. From that point, I'm going to go down 3, to the negative 3, and right 4. And then I'm going to do it again. Down 3 to the right 4. We can also go in the opposite direction. Oftentimes I ask you to graph 3 points on a graph. But we went down 3 to the right 4. We can maintain the pattern by going up 3 and to the left 4. And that will give us a pretty solid value of equations on the line. Here. Now I know that the notes didn't ask you this question, but I don't want you to forget this. What's the domain of this line? And it is. It's negative infinity to infinity. And not only is the domain negative infinity to infinity, the range is also. Now again, there is nowhere in the notes that it asked you that question, but it is something that we addressed in the last unit somewhat. And I want to remind you that any line with a slant has domain and range of negative infinity to infinity. When we look at problem number 2, remember what the direction said. We may need to solve for y first. So on this particular problem, we need to solve for y. We are going to add 6x to both sides. We get 2y equals 6x minus 2. It's 2 times y. The inverse operation is going to be to divide by 2. And we end up with y equals 6 divided by 2 is 3x. 2 divided by 2 is 1. We solve for y. So we can put our equation back into y equals mx plus b. Back into the slope-intercept form. Once we solve for y, then we can identify what's the y-intercept, abbreviated b, what's the slope, abbreviated m. Well, is our y-intercept 3 or negative 1? And at least say it in your head that it's negative 1. Which means that our slope is 3. And it's fine if you just write down 3. But I want to remind you that slope is rise over run. So over here, on this particular problem, we're going to start with b, negative 1. And then we're going to rise. 1, 2, 3 to the right 1. They were both positive. Positive 3, positive 1. 1, 2, 3 to the right 1. And not only can we go up 3 and to the right 1, but from the y-intercept we can count down 3 and to the left 1. Down 3 and to the left 1. Slope is the same all the way on our line. So going up and to the right, which is a positive divided by positive, or going down and to the left, a negative divided by the negative, is the same. And we could draw our line. Take a moment, if you haven't done so already, and see if you can get the next problem on your own. So as we turn the paper over, we've got some special lines. Horizontal and vertical lines. And ironically, these tend to be harder for us than the slope-intercept lines. And maybe it's that we just don't practice them enough. But there's 2 special lines that we often use when graphing, the horizontal and vertical. And what we've tried to come up with is maybe an easier way to help you remember. A vertical line. It crosses or it cuts through the x-axis. So when we write the equation of a vertical line, we write x equals wherever it crosses, which happens to be the 2 here. Something that you may or may not remember from Algebra 1 is that the slope of a vertical line is undefined. That might be something that you need to memorize. The slope of a vertical line is undefined. In contrast, we have our horizontal line. And the horizontal line, we still work with it the same way. What axis does it cross? What does it cut through? Well, this time it cuts through the y-axis. And then when we write our equation, it's going to be y equals, but where does it cross in this particular picture? It crosses at 4. And again, you may or may not remember from Algebra 1 that the slope of a horizontal line is 0. So as we jump down here, some of you are ahead, and that's great. I'm going to do problem 1, and then I'll have you do problem 2. I'll work problem 3, and then you can do problem 4. But in problem number 1, what we're trying to do is we want to figure out the equation of this horizontal line. So remember, when we're working with equations, we ask ourselves, which axis does it cut through? Does it cross? And we can see that it's going to cross the y-axis. And then where does it cross? It crosses at -4. Well, right above, because we were just talking about it, what's the slope? Well, the slope of a horizontal line is 0. If you would prefer to write the number 0, write the number 0. So take a moment and work on problem 2. And hopefully what you see is x equals 7. And the slope of a vertical line is undefined. Problem number 3. 3 and 4, now we're going to be graphing these. X equals -7. Here's -7. Remember, that's where we're going to cross. So our line is going to look like this. It's a vertical line. And just like question 2, the slope of a vertical line is undefined. Take a moment and work on question number 4. Y equals 9. Could be a horizontal line. And the slope of a horizontal line is 0. As we finish here, we're going to talk about graphing linear inequalities. And the thing about graphing a linear inequality is that it's going to require shading. And it never says shade. Shading is implied in the problem. So that might be something that you need to write down in your notes off to the side somewhere, is that we have to shade when we see a less than symbol, a greater than symbol, a less than or equal to, or a greater than or equal to symbol. And I need to approach the notes just a slight bit different here than what this has in terms of shading up and down, because we won't be able to see me shading up or down on a video. But the one thing that we can talk about is that when we have a less than symbol or a greater than symbol, when we draw our line, it's going to be a dotted line, a dashed or a dotted line, however you want to look at it. But when we have an equal to in the problem, the less than or equal to or the greater than or equal to, we're going to write a solid line when we draw our picture. And it's not the drawing the line that's oftentimes the problem. It's that people forget to shade because it never says shade. When we look at problem number 1, it says graph each of the following linear inequalities below. The first thing that I hope we notice is that we need to solve for y to be able to do this problem. So we're going to subtract 2x from both sides. And we get negative y is less than negative 2x plus 5. We are still trying to put this into slope-intercept form. And we're close, but this says negative y. Well, that's really negative 1. So we're going to divide this by a negative 1. We're going to divide this by a negative 1. We're going to divide that by a negative 1. And when we divide an inequality by a negative, just like when we were working with the domain of a square root problem, the direction of the inequality changes. And we're left with y is greater than negative 2x divided by negative 1 is positive 2x. Positive 5 divided by negative 1 is negative 5. And we can identify now our y-intercept, which is abbreviated b, and our slope, which is abbreviated n. Well, our y-intercept is negative 5. Our slope is 2. And again, you may prefer 2 over 1. So when we start this graph, we're going to go to negative 5. And then it's up 2 over 1. Up 2 over 1. And not only can we go up 2 to the right 1, but we can also go down 2 to the left 1. But what we need to really stress, and I need to stress it to myself as much as you need to stress it to yourself, is that this inequality is going to be dotted or dashed because it says y is greater than. So when we draw our line, it looks something like that. Now, for some people, shading is very intuitive. And what that means is you can look at it and you go, oh yeah, I shade right here. And for some people, it is not intuitive at all. You look and you go, I have no idea where I'm going to shade. The thing is, there's 2 parts to this graph. There's a kind of to the left, and there's a kind of to the right. And so that's how some people maybe look at it. But because we're making a video of this, what I'm going to do is I'm going to pick a point that's not on the graph. Not on that line, that red line. And whenever possible, I try to pick the point 0, 0. I'm going to take the point of 0, 0, and I'm going to put it back into the original inequality. And it doesn't matter. You can put it into the one that we just solved. But if we put that back into the original, it's going to be 2 times 0 minus 0. We put 0 back in for x, we put 0 back in for y. And the question is, well, does 2 times 0 minus 0, is that value less than 5? Is 0 minus 0 less than 5? Yes. And because that makes a true statement, where we shade here is where 0, 0 is. And I'm not a fancy shader, but I'll try. But I know there's going to be little white spots. I'm trying not to make too many white spots. But it's going to be in this part of the graph. And I did better than usual. I hope. That part of the graph is where we shade. Again, these types of problems never say shade. Talk to a friend or neighbor around you at some point. Maybe they see it very intuitively and they can go, oh yeah, you just shade here. And maybe they can tell you how they approach it. But that's not going to show up very well on the video. If we look at the next one here, x is less than or equal to -6. When we draw this picture, I think of it as x equals -6, which I'm going to put in parentheses. Is this a horizontal or is it a vertical line? And it is a vertical line. Here's -6. It's going to be a solid line because there's an equal in the problem. And now that we've got that, we need to determine where to shade. Now again, sometimes on the vertical and the horizontal, people see it better than on the slanted lines. But I will show you, again, why. The part of the graph that gets shaded, and by the way, it doesn't just stop here, it keeps going. But roughly, and I know there's some white marks there, but that's that side of the line. Once again, what we can do is we can pick a point that is not on the graph. 0, 0 is not on the graph. If we put 0, 0 back into this equation, the only place that we can put back in here is the x value of 0. But the question is 0 less than or equal to 6? Sorry, but it is 0 less than or equal to -6. And is 0 less than or equal to -6? Because that is an untrue statement, we shade where 0, 0 isn't. Try to finish these remaining graphs on your own. Remember that you might have to solve for y first. And don't forget that it never says shade, but these require shading.